Hello everyone. In this video tutorial, we are going to show you how you can send data from apps running in your camera to an external MQTT broker. We will start with a very simple example, but we will also show you a practical example using ThingsBoard. For the purpose of this video, we are using a camera that runs Security and Safety Things version 1.50. But the ability to send data to an external MQTT broker was introduced in version 1.4. So practically, you can use any camera that runs version 1.4 or higher. We are also using an app called TF Light Detector. TF Light Detector is a very simple app that detects objects in a frame and publishes information about the objects, which we call metadata, on a topic that is specified here. Please do note that this topic is very specific to TF Light Detector. It might not be the same for other apps. Other apps can choose to publish their data in their own topics. Usually, this information is provided by the app developer when he uploads his app to our application store. We are also using a tool called MQTT Lens. MQTT Lens is available in our Chrome web store. It is a test or a debugging tool that allows you to visualize the data that is coming through a MQTT broker. Now that we have covered setup, let's go back to TF Light Detector for a moment. Up until now, all the data that is being published by TF Light Detector is residing inside the camera. To send this data to the outside world, we need to configure the IoT Gateway in the camera. IoT Gateway is a bridge that helps you to transport data from the camera to the external world and vice versa. So to start with, let's try to add a new connection. For the name, you can specify any name, but for this video, let's call it SNSD MQTT connection. Make sure the protocol is set to MQTT. For the host, we are going to use a public test MQTT broker provided to us by Eclipse Mosquito. This broker does not require any credentials, but if you are hosting your own MQTT broker, you can specify it here along with the credentials. The connection has been successfully added. The next step is to add the outgoing topics. So why should we add the outgoing topics? It is possible that more than one app is running in the camera, and each of these apps are publishing metadata in their own topic. So it becomes important that for your use case, you have to pick and choose the right topic that you want to send to the MQTT broker. So for this example, we will use the same topic that we showed earlier. The outgoing topic has been added. The next step is to connect. Okay. Now that the connection has been established, data from TF Light Detector is flowing outside to the external MQTT broker. Let's verify that using MQTT Lens. To keep things simple, we will provide the same connection name as we provided in the camera. Though MQTT Lens does not require that. But some systems like Azure requires that the connection name is the same between the two clients. The next step is to specify the host name. the host name has to be the same as what we provided in the camera. In this case, it will be the Eclipse Mosquito Broker. If the host names are different, then MQTT Lens will not be receiving data from the camera. The connection has been established. The next step is to specify the topic. It is important to tell the MQTT broker in what topics you are interested in. Otherwise, we will not receive any data. Let's specify the same topic we provided in the camera here. As you can see, the moment you subscribe, you are starting to receive data from this particular topic. MQTT Lens is a client that does not have any idea about the camera or the app that is publishing the data. All it knows is only a MQTT broker and a topic, and it is able to receive data. Now that we have covered how data can be examined using a simple client like MQTT Lens, we will learn how to visualize this data in more powerful systems like IoT dashboards. For that, let's consider a practical use case where we want to analyze people traffic in an office setting. Towards that, we have set up two cameras, and each of these cameras point at two different entryways in our office. Here is another camera that looks at a different entryway. We also have installed an app called Simple Counter in both of these cameras. This app detects persons who cross this line. It increases the count in the respective buckets and it publishes these counts. We have configured IoT Gateway in these cameras to send the data that is being published by this app on this particular topic to a particular MQTT broker. Both of these cameras are configured similarly. The same MQTT broker, and it also sends the data that is being published to the same topic as the other camera. We are using an IoT analytics platform called ThingsBoard, which many of you might already be familiar with, to receive this data. As you can see, we are receiving data from the MQTT broker that we specified in the camera, and the topic from which we are receiving data is also the same as what we specified in the camera. Once data has been aggregated, we can visualize this data in dashboards that show the people traffic. For example, this pie graph shows you how people would like to enter, which entryway people would want to use to enter the office. This particular bar graph shows you how people are entering at different times. So for example, you can specify in the past 30 days, like how many people entered through one entryway during a particular day and different times actually. You can also show occupancy trends. ThingsBoard is one IoT platform that we used, but you can use any IoT platform that supports MQTT integrations. With that, we can now conclude this video. Hope you found this video insightful. Thank you.